we have, the mic's probably going to make noise. We have quadratic graphs and their properties, section 9.1. So, quadratic functions have a squared term. So when you look at them, you're going to see that power of 2 somewhere in there. Okay, now it can come a lot of different ways. It can just be y equals x squared. We're going to look at that one. That's called the parent function of all the quadratics. It's one we usually compare things to. We've talked about parent functions before. We relate this original to something else, and we're going to do that a lot in this section. But sometimes we just see one that looks like this. Y equals 2x squared plus 3x minus 5. As long as it has the x squared term, it's a quadratic. It can have an x term. What it can't have is an x to the third term. That would be a different thing. That'd be a cubic. So the highest power has to be a squared. That's one. Okay, it results in the parabola. Now, a parabola is a graph of a quadratic function. We will have parabolas that kind of look like a U. They might open up, they might open down. We'll talk about those. We're going to graph some of those. Okay, they also have what's called an axis of symmetry. The axis of symmetry is a middle line. Now, I'll probably miss here, but the middle line that splits the graph in half. So they both have an axis of symmetry. And if you were to fold that black parabola over, it would match up on either side. Okay, it's got symmetry. The two sides are the same. People have symmetry for the most part. If you drew a line down the middle of our nose, the two halves kind of match up. We all have some things like I got this one finger that I broke playing football when I was in high school, and but for the most part we see that symmetry, right? Okay. The vertex is where the graph changes direction. The vertex is the turning point. Okay. Then we have what are called minimum and maximum. This one here, would you call it a low point or a high point on the graph? Low point, because see the other sides, they go up, right? So that's the lowest it gets. So that one is called a minimum. When we look down at the bottom, if the parabola opens up, you get what's called a minimum point, a min. We usually abbreviate it MIN, min. But that stands for minimum, smallest, lowest point. Then if it opens down, that is the highest point you can have. So we call that a maximum. Abbreviated max. Same thing down here. That's that highest point. The rest of it goes down, so those are lower. Okay. The domain and range, if you take them alphabetically, D and R, and you can remember X and Y, you can remember which go with which. The domain are all the X values. We call them inputs. Usually you input X, and what comes out is Y, called an output. That's also alphabetical, input, output. So all those things, at least they go together with some order. Most of the time, you're going to find mathematics has order to it, even in the way we define terms and things like that. All right, so here we're going to look at this graph of y equals x squared. So we have the simplest graph you can have, y equals x squared. What we're going to do is we're going to take a calculator. We're going to put different things in. The first thing I'm going to put in is x. X, we call it an input. If I input -3 and I square it, what's -3 times -3? +9. A negative times a negative is a positive. So that's -3, 9. Now that is what we call an ordered pair. ordered pair, if we go on here to -3 and then up 9, we would be right about there. See, this one is up 9, back 3. We can see that point. It should land on the parabola that's already graphed there. I think that was on there for you. Now, the curve has symmetry, so something that is really neat. If I were to put in 3 and square it, 3 times 3 is 9. On the other side, this point here, if I were to fold it over that central line, it would match up. And those 2 points, whichever way I fold it, if I fold it left or fold it right, can you see they should hit each other? And it's like a mirror, okay? That middle line, that's the idea of symmetry. So then the same thing is true. If I put in -2, so I'm going to change this. If I put in -2 and +2, what should I get in either case? Both times +4, because -2 times -2 is still +2. And here's the thing, if you use a calculator, there is an importance to math in terms of the order. If I put in -2 and square it, what that is doing is it's taking -2 times -2. That's getting 4. A negative times a negative is a positive. But if I do it wrong, this answer gives me -4. But that's because it's not taking -2 times -2. It's taking a negative times 2 times 2. Because it's only going to take the +2, if I put it in parentheses, and multiply that. It's going to take 2 times 2. So that's why that one would get me -4. It's the importance of putting it in parentheses. So when I put it in parentheses like this and say -2 squared, it's a negative times a negative makes positive. So what do you think you get if you put in 1? Okay. Now, if we graph that, -2 up 4, +2 up 4, -1 up 1, +1 up 1. What happens if you take 0? 0 squared. 0. We land on 0. That graph there is what we call the parent function. It's the simplest graph of all parabolas. Now, the domain. Okay? The domain technically here is still this good old thing. What does that mean? All real numbers. Because I could put in more numbers. I didn't have to stop at -3, -2. These numbers, the inputs, they're the domain. But I could put in -4. I could put in +4. I could put in -100, +100. -1 million, +1 million. I'm still going to get answers. So I can put in all numbers. But the range, however, does the graph ever go below this line here? So the range is y is greater than or equal to what? What's the lowest it gets? 0 is the lowest it gets. Okay? And we've seen that before. Y is greater than or equal to 0. Okay. Next, it says, identify the vertex of the parabola. So the vertex, if you look back to the first page, the vertex is the turning point, the place where things change. I don't remember what we had on here. It's the where the graph changes direction is how we put it there. But it's the turning point. If we look, this point here, that's the vertex. And what you're supposed to do is you're supposed to come up with an x and a y coordinate for that. What is it on x there? -2. And then y, we have to go down how many? More. -3. To hit that vertex, you have to go down 1, 2, 3 squares. right? -2 to the left, down 3. So that is our vertex. Can you, for this one, the second one, identify the vertex? Write it on your own. Don't say it, please. And then we'll check in about 10 seconds. What do you got? 0, 3. Because we didn't move any on the x, but then we went up 3, right? Okay? Now, is in part A, back to the first one, is it a high point or a low point on the graph? It's a low or lowest point. How about this one? Part B. So then you have to determine, is it what we would call a maximum or a minimum? Well, if it's the lowest point, it is a minimum. Highest point, it is a maximum. So just getting some basic terminology down with that. Does that make sense? Okay, so now we're going to graph these, and we're going to graph along with the parent function. So this one, it's already got the parent function on here. So we're going to go through, and if you do have a pen and a pencil, maybe this is the one you want to put in pen since there's the original. If you don't, then I can show you what we can do so you can kind of see the difference. But on this one, the parent function is just the original graph. So I'm going to go through and I'm going to put 0, 0. That's that point. That's going to be our vertex. Then I'm going to go over 1 and up 1, left 1 and up 1. That's the -1, 1, positive 1, 1. I don't want to go too fast. Do we have any questions on what I'm doing there? So all I did is graph those 3 points. Now, truthfully, that's enough, but we're going to graph these as well. We're going to go -2 and up 4, and then we're going to go +2 and up 4, and then we're going to get an idea. So with this one, I'm going to make this kind of a dotted line just so we get, this is our parent function. That's the original. Okay? Now, a parabola, when you graph it, what you'll notice, some students do it incorrectly right away. When they graph this, they don't get the idea. They make it kind of like that, where it's not smooth. But a parabola, actually, when you graph this thing, it should be a smooth curve. And you have to kind of learn how to do that. But can you see how that's what you want, is this idea of a smooth curve when you graph it. So the reason I'm graphing this one with the dots is just to get the idea. That's the parent. That's the one we're going to compare it to. If you have a pen, you could just put it in pen, and then the other one's in pencil. You know what we're going to do with the second one. So let's take that and let's graph on all these. All of these we're asked to put the parent on there. So I'm going to do this again. I'm going to graph a 0, 0, 1, 1, -1, 1, -2, 4, +2, 4. Okay, so what we've got on there, all of them, we have the original parabola called the parent function. Now we're going to compare it in the next one. Okay, so in the next one it says we've got the graph, or back to the first one, we have 3x squared. Okay, so I'm going to get a fresh page on here. 3 parentheses x squared. I'm putting in 0. What's 0 squared? 0 times 3 would be 0. Should make sense. Okay? Now I'll put in -1. If I put in -1, -1 squared is 1 times 3 is, and you might say, why are you doing it in that order? We have the PEMDAS rules. We do exponents first, then we multiply. Okay? So that gets us 3. Now if I go up and I were to put in +1, that also gets me 3. Okay, so I'm going to start with those. This got me 0. This got me 3. Now notice, if I would have just took the 1 and done what, I could have got that. I would have took this 1, taken this 1, multiplied by 3. So what do you think this is going to get me here? For the when I put in -2. Okay, we think it's 12. Let's see if we're right. Okay, we'll put that in. Put in -2, we get 12. Put in +2, we got 12. Sure enough. All right. So now to graph that, I'm going to keep the purple on here. The 0 didn't change. At 1, it goes up to 3. So are my purple dots taller or shorter than the black graph? The dotted one. Taller or shorter? Are they above or below the black graph? They're below it? See, like right here, I mean, you'd call that below. Are they above it or below it? They're above it. Okay? I mean, here's the graph. If I'm here, I'm above it. Okay? Now, if I go to 2, 2 is at 4, but now it's at 12. 12 is up here. Notice it's a lot taller than what this point was, right? Okay? So what we get is we get a graph that's much taller than the other. Well, what do we call that? Okay? We call that down here, we're going to get a little bit ahead of ourselves, but we call it a vertical stretch of 3. It's 3 times taller. Now, what's our new vertex? Our vertex still is what? Where's the turning point yet on the new graph? 0, 0, 0. Remember, the vertex is a point, so it needs coordinates. Is that a max or a min? It's a min. But now we have something new we haven't talked about to this point. We have what's called the axis of symmetry. Now, the axis of symmetry is the middle line. That middle line goes through at x equals 0. It will always match up to your x coordinate. But why x equals 0? As you go across the line from left to right, it lands right in the middle where x is 0, and then it's an up and down line, but that's where the fold would be, right? The domain, still all reals. We could put any number in, but the range is y is greater than or equal to what? Never goes below what? 0. Okay. So now we want to try the next one. What's going to happen if we take this x squared? What thing did we put in front of it now? Okay, a -4, right? So if over here it just multiplied by 3, what do you think we're going to do with all those numbers now? Multiply by -4. So what do you think you get here? 8? No, not 4. 16, we're getting closer. What did you say? -16, because it's going to be times a negative. This one should be -4. This one should be 0. Doesn't matter if it's negative or not. And, okay, now let's see if that's true. But all it did is take the parent and multiply it by -4. Let's try it. -4. And if I put in -2 squared, I get -16. You might say, wait, a negative times a negative is a positive. So why isn't that 8 and then 8 squared is 64? That would be incorrect math. Math does parentheses first. So -2 times -2 is +4. And then 4 times -4 is -16. You see that? You have to do the exponent first. So if we put all those in, that's what we're going to get. Now we're going to try to graph it. 0, 0, 1, -4, -1, -4. And then somewhere way down here off the graph, it's at -16. So this one, it did a couple things. It did what we call a vertical stretch. It's definitely taller, but at first did a reflection on the x-axis. Do we remember talking about that before? And then it did a vertical stretch of 4. The reflection was caused by the negative. So the negative flipped it. Now, sometimes I call a parabola, when we look at a parabola that opens up, I act like that's a smile. Okay? Parabola that opens down, frown, right? Because it's negative. Okay? And that's the idea. Well, this one's negative, so it opened down. All right, what's our vertex here? 0, 0. Now, if you look at, 0, 0. If you look at that, that'll tell you the axis. X equals 0. Is it a max or a min? This one's a max. It's a high point. Our domain? All reals. But y is this time, since it goes down, less than or equal to 0. Good. Okay. All right, the next one, it says half. Huh. Well, let's try it, just in case. What's half of 4? 2. So half of -2 squared, -2 squared is 4, and half of it is 2. Oh. Okay, so I think if I fill this one in, I'm going to get 2. Then I'm going to get a half. I'm going to put it as 0.5. What's half of 0? 0. And then I'm going to get 0.5. And then I'm going to get 2. Vertex is 0, 0. Is it a max or a min? What do you think? We haven't graphed it yet. Did it have a negative? Is it going to open up or down? Up. So I think this is going to be a min. Okay? But we'll graph it and see. 0, 0. Now look at this second graph. 1 and a half. -1 and a half. Notice how those dots are below the parent graph. Okay? Then 2, 2, -2, 2. Axis of symmetry, x equals what? Domain? Since it opened up, y is greater than or equal to 0. That's it in this section, isn't it, everyone?